In this video, I'm going to show some of the highlights when programming a part in GibbsCAM, as well as a little bit of Kennametal NOVO and ToolManagerIQ. It usually starts by getting some files from the customer. So let's say today I was tasked with programming this gear housing, and I was sent a PDF drawing, which shows me all of the part dimensions and different information. And if I did have to draw the 2D wireframe or create a solid model, I can definitely do that in GibbsCAM. But in this case, the customer was nice enough to also send a finished 3D model, so I can save some time by bringing that directly in. There's a couple of different ways to do that, but I'm going to go in the document control dialog and make sure that the proper machine is picked, maybe the material I'm machining, units, and in the end I'm going to open that solid model. As far as formats are concerned, there are several popular 2D formats like DXF and IGES, as well as 3D formats like Parasolid, Step, SolidWorks, etc. So you simply pick the proper one or all files, and now I can bring that part in instead of having to draw it myself. Another nice thing about that is it shrink wraps on the part. So if the part is off in the distance because it's part of some assembly, then it'll find it instantly and also give you the dimensions, which can be very useful on a part like this that doesn't really have any straight edges in X or Y. There's also tools to align the model if it's on some weird angle, so that you don't have to spend hours trying to get it in the right spot. Before I close this, I'm just going to enter the stock size that was given on the print there. And maybe I want a different clearance. And in the end, I'm going to have that part, as well as some stock to cut the part out of. And that's usually when you're ready to get some tools. So I'm going to jump over to Kennametal NOVO to do that. Now I'm in Kennametal NOVO, and let's say the first tool I'd like is a face mill. I'm going to start searching. Let's say it's a milling tool. I'd like one with indexable inserts. We'll go to the face mill section. Now I end up with quite a few items, but at any time I can apply filters to cut those down. So I'm going to say that the material I'm cutting is non-ferrous, since it's aluminum, and I'd like a diameter of 3 inches. And that'll give me less items to look through. I'll pick the KSOM, select this one here, and at the end of the road I have 2 items that match that. There may be one, there might be more, but each row will give you some information so you can compare them. You can also click on them to get more details about it, images, dimensions, extra things that it has. And when you're happy, since I'd like to add some inserts and an adaptive backend, I'm going to create a new tools assembly. And I'm going to call that 3-inch KSOM. Now I can pick an insert the same way here. My filters are already applied, so I have one for aluminum. More information if you want to look at it. And I'm going to add that to the tool assembly. Same with the adaptive backend item here. I'll add one with a Cat40 adapter. And there's more items with different dimensions. I'll pick the one I want and take a look at the information, and again, add to tool assembly. And it will show different support items, and when I'm happy with it, I can download the model so I can bring it into GibbsCAM. Now here we do have an option to get a fully rendered model that would have every insert, nuts and bolts, and look like it wasn't spinning. but often the anti-collision model is better because it'll just be a spun body, less detail to calculate, and the tool is going to be spinning when you're using it, so it'll oftentimes look better in the simulation. So I'm going to download the current assembly, and I'll get a step file that I can bring into GibbsCAM. And there it goes, it's putting it together, and there's my 3-inch KSOM step file that I can bring in and use as a 3D form tool. I'm back in GibbsCAM again, and I'd like to bring in that tool. So first, I'll send the part to the body bag to get it out of the way, and I'll do an import, which is pretty much like how I got the part in. And there's the file I downloaded, and this is going to read it into the current program and give me the progress here. So I'll wait for that to finish up. And we can already see something, and in the end I have 3 solid models that represent the 3 items in my assembly. And notice the spun body, which is much less detailed, so it's quicker for the system to calculate, and the body will be spinning when you're using it, so the tool is going to look proper in the simulation. Next up, I'm going to open my tool list and create a new tool, and this is going to be a 3D form tool. I'll select the cutting portion and press apply, and this error is no problem. And here you can see the representation of the inserts. I could say that that is a 3-inch nominal diameter if I'd like. For the holder side, you can definitely add these pieces together, but if you don't want to see the back end, that's no problem. We can just use the body that holds the inserts. I'm going to select a custom holder, select that, and say use selected solid. And there you can see it appear, and that is the tool that's based on my 3D assembly. The cutting portion is in white here, and then the holder portion is in red, so it will collision check and tell you if it's hitting the red portion. And there's some extra information I can put in here, possibly how many inserts it has. There's a way to put the holder at 0 so the hangout is also accurate, but I'll leave it at 0 since it's in place already. My offset numbers, maybe this is carbide insert or coated carbide insert. I could even add some cutting data, which could come from the Kennametal NOVO site or any other site like that. And maybe I'll say this is the 3-inch KSOM. My tool's done, so at that point I can close it. I could send these to the body bag as well, bring my part back up. Now I'm ready to start programming using that tool. And of course I could do the same thing with every other tool, but I'm not going to make you watch that, so we'll do a little video magic instead. Now that I have some tools, I'd like to tell them what to do. So if I want to create an operation, I'm going to open up the CAM portion, which has the process list and the operations list. And the workflow is incredibly simple. I'll drag the tool down I want to use and select what I want it to do. I'm going to do face milling with that tool that I downloaded. Then I can enter all of my parameters, and they're all there in the same spot, nice and easy to find. Things like feeds and speeds that can be brought from the database or calculated. Clearances, what I'm going to cut, passes, pattern, etc. And when I'm happy, I press do it, and that creates an operation tile on the right hand side here, which is my finished program, and also shows the path it'll take. But if I want to look at it a little bit closer, then I can always go into the simulation and watch it cutting. And there you can see the form tool that I downloaded. I can check for collisions, make sure everything looks the way I want, and then I can move on to the next operation. But once again, I'll do a little video magic so you don't have to watch that part. Once you've finished your operations and you're happy with how your program looks, that's when you can use a post-processor to create the proper G-code for your CNC machine control. But you may also want to use ToolManagerIQ to back up certain items in your program. And that could mean fixturing. You can see you can add fixtures and fixture assemblies to this database. But in this case, I'm going to save the tools. So I'll go into the tools section. And the programmer is usually who at least starts adding items. So I'm going to select the tool or tools that I want to add in Gibbs. And I will import them from GibbsCAM into ToolManagerIQ. And that's going to pre-populate everything for me, so I don't have to enter all of the information manually. And there's also some additional functionality like grouping that can be really great. So I'm going to make a new favorite group, and I'm going to call this one gear housing. But this could be by anything. So it could be by machine, tool type, material, etc. And now anyone that's on this database will be able to see that's the tool list I need for that program. I'll just go ahead and add all of the tools. And there you can see my holder, my custom holder is being added, and I can say maybe that it's a Cat 40. Press OK. And now those are all in the database, and me or someone else can go ahead and find that group. So if I go to the gear housing, there you can see the tools I just added. And this is incredibly useful because it's saved on a SQL database and anyone can access it. So whether it's the programmer that has this integrated version of ToolManagerIQ and works inside of GibbsCAM, or the standalone version of ToolManagerIQ, which anyone can run without GibbsCAM at all. Really just the same thing without these buttons. And that means that whoever needs to see the information and add more information can do that, and everyone stays on the same page. So at this point, that might be, what the programmer does, and now maybe it goes to a tool crib employee that takes a look at the list, sees the stock, picks what tools that they have, notes what ones have to be ordered that aren't in-house, and they can do that easily just by opening the dialog here, add some item numbers if he knows what they are, change the picture here. I downloaded the KSOM picture. The item number will generate a barcode that could be printed and scanned. And there's also a whole supplier section here. So I could select some kind of a supplier there, press OK, and now that's all saved on the database. From there, it might go to a purchasing employee who has to take a look at this and say, okay, you need this face mill from this supplier. And say they go to the suppliers, and if they need to enter any kind of contact information for whoever they're dealing with, then they can do that as well, which again keeps everything so that anyone can see it, and when it's time to order those tools again, they know where they came from. So it's a very handy tool to have, and if you have any questions at all and you've enjoyed this demo, feel free to give us a call. Have a great day.